In this video, we'll be talking about the importance factor and more importantly, why this importance factor is so important when it comes to the seismic design. So without any further ado, let's jump inside the video. Hello and welcome to Civil Black Box. This is where we talk about concepts related to civil engineers. So if you're new, do consider subscribing, and during the video, if you like the video, please do not forget to hit that like button. With that said, let's jump inside the presentation. So in this video, we'll be talking about the importance factor and why it is so important in seismic design. Now, when it comes to the importance factor, the concept of importance factor is derived from the IS 1893, which is the code for criteria of earthquake-resistant design of structures. Now, this is where we talk about a concept called the design horizontal seismic coefficient, which is AH. And AH comprises of Z by 2 multiplied by SA by G divided by the response reduction divided by the importance factor. So the I here is what is really, really important. So if you just look at this I, this is what is important. You can check out one of my other videos as well regarding this whole AH calculation as well as the seismic calculation. Now, when we think about the importance factor, what we think about is just the IS 1893 part 1, because that is what we usually go through. However, the Indian Standard Code 1893 has different parts associated with it. These parts are part 1, 2, 3, 4, 5, and 6. The first part is what we generally look at, which is the general provisions and buildings. Now, the code was launched in the year 2016 and the latest reaffirmed version is 2021. Now, if you want to get the latest version of any code, do check out my previous video on how to download any Indian Standard Code for free, the latest versions of it. Then we have the IS 1893 Part 2, which is for liquid retaining tanks. Again, 2014, reaffirmed in 2019. Part 3 is bridges and retaining walls. Part 4 is industrial structures like stack, including stack-like structures. Part 5 is dams and embankments. This code has been mentioned in one of the codes, or rather all the codes of IS 1893, but it is yet to be formulated. It has not been launched yet. And finally, we have a very latest version of the IS 1893, which is part 6, which is base isolated buildings. Now, why I'm showing you this is because the IS 1893 is not just the part 1. So the importance factor is not only derived from part 1, but from all of these parts. So if we go through the IS 1893 part 1, Section 6.4.2, you can see this is where we talk about I. Now, the I mentioned here is simply importance factor given in IS 1893 from parts 1 to 5. So it is clearly mentioned that it is talking about parts 1 to 5 for the corresponding structures. Now, when not specified, the minimum values are given as follows. So for 1.5 for critical and lifeline structures, 1.2 for business continuity structures, and 1 for the rest. So this is kind of the overarching principle on which the importance factor is taken. But again, it is said that the importance factor is for corresponding structures. So it differs for different structures. So let's have a look at it. So this is 7.2.3 again from part 1, which talks about in estimation of VB, we take the importance factor of building as per table 8. The table 8 is given as follows, where the important services are given a value of 1.5. Now, these important structures include critical governance buildings, schools, signature buildings, monument buildings, lifeline and emergency buildings, for example, hospital buildings. So hospital building is one of the very important structures. We have the telephone exchanges, television station buildings, radio station buildings, and you get the gist of it. So any important service or community building or structure falls under this criteria, which has an importance factor of 1.5. Any residential or commercial buildings other than those listed right here with occupancy more than 200%, will get an importance factor of 1.2. And finally, for all other buildings, we get an importance factor of 1. Now, in continuation to this, we have a few notes also given, which says that the owners and design engineers may choose a value of importance factor more than those mentioned. Now, just remember that it has to always be more and never less. So you as a design engineer will have the opportunity of taking an importance factor more than that mentioned, but you have to do so diligently. And we'll talk about where these values are taken higher also. So this is with respect to the part 1. If we head over to the part 2, which talks about the liquid retaining tanks, again, as per clause 4.5 of this part 2, it is mentioned that the importance factor is given in table 1. If we head over to table 1, you can see that the tanks which are used for storing drinking water, non-volatile material, low inflammable, etc., and intended for emergency services like firefighting services, tanks of post-earthquake importance are given an importance factor of 1.5. All other tanks with no risk to life and with negligible consequences to the environment, society, and economy are given a value of 1. Now this is as per part 2. Let's head over to part 3, where 9.4.1 talks about again the same formula, which you can see AH is Z by 2, I by R, SA by G. Right here it is saying that the importance factor is taken as per table 2. If you head over to the table 2, you can see for the normal bridges, that is all bridges except those mentioned in other classes, we get a factor of 1. For the importance factor, rather the important buildings, let's head over to the important buildings which have a value of 1.5. So I'll just mark it quickly. So these are everything which have a value of importance factor of 1.5. So these will be long bridges with more than 1 kilometer length across perennial rivers and creeks, bridges for which alternate routes are not available, all important bridges irrespective of routes. Again, the major bridges on group A, B and C routes. Route classification will be as per the IRP way manual. Again, you have to go through all that. These will be given a value of 1.5. Rest will have different values. So again, if you are designing such structures, it is very important to just not be limited by IS 1893 part 1, but rather go through the exact part. Let's head over to the next part, which is part 4, which talks about the industrial structures, including stack-like structures. Again, the formula is the same, Z by 2, SA by G, I by R. The importance factor is given in table 3 and table 9. So there are different structures for which different importance factors are given. Again, table 3 talks about the importance factors with respect to the category of structures. And you can find the category of structures as per one of the tables mentioned here. So you can see 8.1 for the categories of structures. So for different categories, you can see the importance factor is different. For category 1, you can see we have a value of 2 as the importance factors. If you head over to the other table which was talked about in this code, that is the importance factor I applicable to stack-like structures, you can see we have reinforced concrete ventilation stack, which have a factor of 1.5, reinforced concrete chimneys, again 1.5, reinforced brick masonry chimneys for industry, again 1.5. You can see reinforced concrete TV towers, 1.5, steel stacks and silos, again 1.5. So depending upon the different kinds of structure, you get the gist of the whole thing. The more important the building, the more important the greater the importance factor. So this is what we realized so far, that the importance factor is linked with IS 1893 and the value is I. Again, in this formula itself, you can see that the I is going to be directly proportional. So the value or the force of the earthquake or the seismic force is going to be rather directly proportional to the value of I. So the greater the I, the greater the force which we are designing our buildings for. And that is why the importance factor is increased for more important buildings. So the greater this value, the greater will be this value, the greater will be the seismic resistance of the building, or rather the more resistant building we are designing. Now, this is not the end of the story. Importance factor with respect to hospital is something which is a bit different. Now, with respect to the hospital buildings, we are not just talking about IS 1893, but rather we are talking about the NDMA guidelines as well, which are the National Disaster Management Guidelines for Hospital Safety. Now, this document is a bit old. This was launched in 2016, and we are now working with IS 1893 2021 version. But nevertheless, these are guidelines which have to be followed stringently with respect to all the conditions given in India. Now, as per this guideline, we get an importance factor of 2i. Now, this is not explicitly mentioned right in NDMA, but I'll show you what is exactly mentioned. NDMA gives a value of AH a bit different. Being a hospital building, the importance factor is assumed to be 2i, that is 2 times the importance factor. So in a usual case, a hospital building will have a value of 1.5. In this case, a value of 3 will be taken. If we boil down this formula, you can see the 2's get cancelled out and we get a formula which looks something like this. So Z multiplied by SA by G divided by R by I. And this is the formula which is mentioned in the NDMA guidelines. Indirectly, you can assume that what has changed in this whole scenario is the value of I being taken as 2i. So I'll take you to the NDMA guidelines as well. If you go through clause 5.2, which talks about the expected performance of hospitals, it talks about 2 different classifications of hospitals. The first type is the critical units of hospital buildings. Now, these are going to be hospitals which provide medical assistance, which is essential in the immediate aftermath of the disasters. And then there are other type of hospitals which may not be required in the immediate aftermath of disasters. So we have a criteria where the critical units of hospital buildings will be the one which are going to be catering anything which happens just after the earthquake, and the other hospital buildings which are not specifically designed for that purpose. That is the only key difference here. So if we talk about the critical units of the hospital, so you can see the critical units of hospital shall be designed for this value right here. If you can see at the bottom, this is what we are designing our structure for. Z divided by 2 is gone, and that is basically gone because we have increased the I value. That is the importance of the buildings. So now if we talk about just the hospital, we have one more guideline which are included right here. Again, just to mention that the NDMA guideline is a rather older version because it was launched in 2016. We have yet to receive any amendment or reaffirmations about the guideline itself. So just take that with a grain of salt, because the IS 1893 Part 1, which talks about the general provision of buildings, is the more latest version, which is reaffirmed in 2021. But nevertheless, we have to design our hospitals, which are specifically for providing support immediately after the earthquakes, have to be designed with a double importance factors, that is a value of 1.5. So I hope I have stressed on the importance of importance factor, especially with respect to the hospital buildings, where you have to increase the importance factor by a magnitude of 2 times, and that comes from the NDMA guideline. So whenever you're designing any structure, do not ever be just focused on IS 1893 Part 1, but rather be focused on what type of structure you're designing, because for every different structure, there is an importance factor. And for the hospital buildings, if you are designing a critical hospital, that is important in the aftermath of the earthquakes or any disaster, that has to be designed as per the NDMA guidelines, which talks about the importance factor being taken as 2 times the value given in IS 1893 Part 1. So I hope this video was a bit helpful for you. If you like this video, do hit that like button. Thank you for watching, and I'll see you on the next one.